So hello again. Tonight we're going to talk about from lead balloons to orbital airships. Once you see this slide, you'll see how the dots connect together, so to speak. Yep, it's a bit of a clickbait title, but that's what you got to do to get the eyeballs on YouTube. And who knew there was actually a Unicode font character for a clown head? But there is. That's not a graphic that's actually a character in the Unicode character set, including the color. So anyway, whenever you look at somebody attempting something for the first time, it's easy to poke fun at their failures. It doesn't always work the first time, and especially if you've not done enough research to understand what the boundaries are. So most first-time efforts have a tendency to fail profoundly. You might get some of it right, other things not so right. That leads to it not really working as you expected. Or the technology that you need to actually make it work doesn't exist yet. You're not aware of it existing and therefore have no access to it, or it's profoundly expensive, like semiconductor fabrication, and don't have access to it, leading it to, well, somebody else is going to have to carry the financial ball until it comes to fruition. Sometimes something is discovered, seems to be meaningful, but no specific purpose at the moment in time that it's uncovered. And you sort of lay it aside, and somewhere down the road, it becomes much more dominant. Sometimes you find something and go, well, that's interesting, but you don't see that it has any perceived value at all.
Yeah.
Who could ever want this? Why would that ever be useful? And then later on, somebody finds it's very useful, just not for what you intended. Kind of like the Nobel Prize for laser tweezers, for optical tweezers in X-ray microscopes. Who knew that lasers could be used to shove molecules and bacteria and viruses around?
I didn't.
And then again, some concepts go on for decades, never getting it sufficiently right to be practical. And no, I'm not speaking about fusion. I'm speaking about other things. And if you don't keep progressing it, if you don't keep, as the saying goes, pushing the envelope further, then you may find that somebody who gets a clue makes a gigantic leap forward and leaves you in the dust. And all of your efforts, all of the money you spent on it are just for naught because it's now old hat.
Yep.
But that's the nature of discovery versus usable practicality. So here's a common urban legend. There was a guy named Robert Goddard. You might be aware of him.
Yeah. Yeah.
When he was a teenager, he was trying to create a durable, heavier than air balloon that would fly to space, not just the upper atmosphere, but to space, because he's a teenager. What did he know? So he built it out of what he knew to be durable at the time, which was aluminum. Now, this is back in the, I guess, the mid 19 teens. So aluminum foil, as we have it today, was not that thin. It was thicker, heavier, not as solid, has pores in it. So he tried using an aluminum balloon. The urban legend is he used lead because it's funnier to say he tried having a lead balloon fly. But even as aluminum back then, it was too heavy, too leaky. He couldn't make the seams good enough. So he gave up on it and went on to develop liquid-fueled rocket propulsion engines. Good thing, too, because, otherwise, where would we be? But today we have helium-filled, ultra-thin polyethylene balloons that we loft to the stratosphere. Not to space, because they kind of stop at the upper atmosphere. They don't actually go all the way out into space because they tend to pop. They get, the air pressure on the inside, the helium pressure on the inside causes the balloon to just expand until it bursts. But they found a way around that. They actually let the helium leak out under a computer
Ah,
control. So they've had helium-filled balloons that have orbited Antarctica, just orbited the South Pole for 60 plus days, and they don't explode. And in fact, they let even more of the helium leak out so they can easily recover the expensive multi-million dollar telescope that's hanging beneath it. So,
uh-huh.
yeah, it's not a hard shell. It's still a soft shell, but they just monitor the pressure. And if you want to stay at a certain altitude, it's kind of like the inverse of buoyancy underwater. Underwater, you inflate your buoyancy to lift you up in the water. So you're still below the surface. You're just at a certain level based upon you and the inflation. Flip that around the other way, and you let the helium expand up to a certain level of pressure, a certain size, and you can hold your position in the stratosphere. Of course, you're losing helium all the time as like the sun heats it up, makes it expand more, you get to let out more. But if you're in a cold environment like the upper stratosphere, the temperature outside is usually pretty low. But, you know, the concept of high altitude balloons wasn't really far-fetched. They just lacked the optimized balloon materials back in the day. That and, you know, Hindenburg, helium versus hydrogen. Helium is more expensive and harder to come by in mass quantities, but it's safer. And if you want to get into space, a balloon's not going to cut it. You need currently chemical propulsion to get you to space. Well, the next step they said was, well, this liquid fuel, this chemical-based propulsion, doesn't really work that well if we want to fly from like asteroid to asteroid in the asteroid belt, because you need continuous propulsion for months at a time. Ion propulsion, when they first came out with it, was deemed the force is so minuscule. Who's ever going to make that into something useful? And they said, well, you know, we can use it in deep space because we don't have that problem with gravity. And they started testing it, and they found out that after less than a month worth of running the engine, the exhaust grid would get clogged up by charged particles of whatever you're using for your fuel, you know, xenon or krypton or whatever. And they found that by having a little ejector on the outside edge of the grid that just spewed out unionized gas molecules, that that would take the charge off the exhausted gas molecules, and your grid wouldn't clog up for years. So if you ever look at an ion propulsion engine, or what they call a Hall effect engine, you'll see right at the top of the circular grid what looks like a little nozzle. Every time that nozzle turns on to deionize the grid, it is wasted fuel. Once they leave the planet, they have no more fuel. So if you run out, it's end of mission. Which is why photonic propulsion is still, I think, a future waiting to happen. It's just as minuscule as ion, but you don't need any fuel tanks or heaters or plumbing or a neutralizer. But, you know, we use ion, and, you know, every one of those Starlink satellites up there has a krypton or argon ion engine for positioning itself in orbit. Then we have the really, really long-term projects. In the 1400s, Leonardo da Vinci authored a bunch of diagrams about flying vehicles. And one of them looked like this weird corkscrew made out of fabric and wood with some guys down at the bottom, like pushing a turnstile. Okay, I get it. He wanted to corkscrew the air to get it to lift off the ground. Lofty goal. Problem was, even the fabric would be collectively too heavy to lift it hard enough to compensate for the multiple people turning the turnstile. No motors, no electricity, no jet turbine engines. That's as far as you're going to take it. But it gave other people ideas. So in 1907, doesn't sound like that long time ago, but in 1907, a guy over in France created a two propeller kind of a helicopter. It could get 1 meter off the ground before the pilot was exhausted. They then motorized it, and they created what is known as an autogiro. It's also spelled auto-gyro, depending upon Greek or not. Non-vertical takeoff and landing. So it needs a bit of a runway. It's a short takeoff and landing. The propeller in the original autogyros is at a fixed tilt. So you would have a propeller that would get you moving horizontally, and the overhead propeller was just spinning loosely and was basically a rotating wing. And that would get you off the ground. You could fly around on it. And when you wanted to come in for a landing, you would cut your horizontal propulsion, and the propeller would gently set you back down on the ground, and you would roll to a stop. Those things still exist, but they're far more advanced, and they found a way to actually tilt the rotor on top, more like a helicopter. But speaking of helicopters, there was a guy named Sikorsky and others that finally figured out, if instead of having two rotors, one on top of the other, spinning in opposite directions to offset the counter rotation, why not just put a 90-degree propeller at the back? And you spin it, and it stops the counter rotating. So that's in 1939 where the Sikorsky helicopter came from. Tail rotor. Fancy that. No wings, no rudder, but a tail rotor. In 1947 was the first time they applied a turbine engine to a helicopter. Before that, it was direct drive, fuel burning engine. Then in 1947, somebody took a jet turbine engine from a Boeing plane and put it in to drive a helicopter. Of course, nowadays, most helicopters that are that size have dual turbines in case one goes wrong to let the aircraft down. But nowadays, you've got helicopters everywhere. You've got multiple rotor drones. They're used in personal entertainment, commercial aircraft, taking pictures from overhead, law enforcement, and the military uses them. And remember, up until recently, we had the Ingenuity helicopter on Mars. Sometimes the basic concept, like what Da Vinci put forth, just takes a long time for the technology to catch up with it to make it practical, even on another planet. So there was this thing discovered called corona-generated ionic wind propulsion. If you throw a charge through the air will ionize, and that will produce a wind. And you can use that wind to actually lift something off the ground as a vertical propulsion. In 1959, they started playing around with these things, and they called them lifters because they had no batteries or electronics on board. They were foil and little sticks of balsa wood and copper wire, and it had two wires coming off of it that went to a high voltage power source, because that's what you need in order to ionize the air is 20,000 volts or so DC, and it would lift, and it would lift pretty ferociously. Like it would strain at the wires like zip, and in the links at the end, I've actually got a YouTube video where you can see one of these things. And a guy built a larger one, that's the second picture you see there, and realized the value of it. So he did that in 2006. It flew for several minutes on an external power supply. So he realized, I better get my name on this before somebody else connects the dots like I did. So in 2014, he filed the patent for electrostatic propulsion for aircraft. In 2018, when we finally had the electronics and battery technology sufficient and the materials sufficiently light, in 2018, some students at MIT built a winged aircraft. And you can tell how lightweight the wings are because the electrostatic force and the weight of the aircraft actually swept the wings upward. When they took off, the wings were down, and then as they lofted, the wings bent upward. Yes, it's an early attempt. Yes, nobody was on board and didn't fly for all that long, but the length of the flight was roughly the distance that the Wright Flyer flew at Kitty Hawk. So if you think about Wright Flyer, 1902, where are we today with jets? Think of this as the Wright Flyer of electrostatic propulsion. There is a company in Miami, South Miami, called Undefined Technology, or Technologies, sorry. And in 2022, they flew a battery on board, computer controlled electrostatic airplane, nobody on board. It flew untethered for 4+ minutes. And it gave them enough faith that maybe in 2024, they will start carrying small cargo. So when you see these drones that will drop a package off at your house, or a drone that can fly a camera, it may be the electrostatic is how things go in the future. But just keep an eye on them. The Silent Ventus was their last one. The next one is much larger and it has an actual shell on the outside of it. So often there are things that are discovered, not useful at the time, discarded, discovered later, and then actually become very popular. People have come to realize, probably by my presentations, that there's a thing called the fast Fourier transform. The Fourier part named after Joseph Fourier. He did the work in 1822, but in 1805, Carl Friedrich Gauss, mathematician extraordinaire, actually uncovered the transforms for discrete manipulation of joined values. He was looking for how to separate out the orbits of asteroids in the asteroid belt. So he wanted to calculate, if I judge where this asteroid is and this asteroid is, and they're interacting with one another, and I find another value, it could be that there's another asteroid I haven't found yet, and that would allow me to predict by the perturbations where the other asteroid would be. Of course, he found another way of doing that, so he just sort of set aside this whole discrete transforms mathematical capabilities and actually didn't publish it. It was just left in his notes to be found much later. In 1965, there were two guys named Cooley and Tukey that were trying to figure out how to detect nuclear bomb tests, underground ones, because we had these test ban treaties for ground level and air burst. Those are easy to detect. They go boom. But when you bury them deep enough underground, you don't see the boom. So if some other country, whether it be the US or China or Russia or Pakistan or wherever, detonates an underground nuclear device, you're not going to see it. Of course, nowadays we see it by satellites, but back then in the 1960s, you wouldn't see it, except that it created earthquakes. And since we have seismometers all over the globe, if you discover an earthquake that's less than magnitude 4, you had to ask, was that a real earthquake or was that an underground nuclear detonation? And what they found was, through fast Fourier transform, in a few days, you could discover whether all your seismometers just detected a underground nuclear test or just a common variety earthquake. But nowadays, since we have digital signal processing to do the FFT algorithms, and they're basically open book, read algorithm, implement in software, do it, they're used to pick signal out from background noise in wireless communication. So your mobile phone uses FFT. Radio astronomy, even the amateurs using software-defined radios use FFTs. And it's become so commonplace that in my software-defined radio application, it's just a little checkbox. Would you like an FFT of that? And you check it, and just in real time, there's an FFT. So sometimes you just have to wait for the right stuff to come along, and then it just becomes, oh yeah, turn on the FFT. Sometimes things come about that don't seem to be usable initially, and people pick it up, try it again. Still not catching, not catching any treading on it. Set it down, pick it up again later. Other people do work on it. Set it down, pick it up again later. So in 1899, Marconi worked with a way to do selective reception. So it's basically if you tune to a radio on a certain frequency, you might have distortion on that frequency. But if you transmit on multiple frequencies, you can move around to different frequencies until you find one that doesn't have interference. Well, Nikola Tesla in 1903 patented hopping around to different frequencies. And the early adopting television broadcaster, Telefunken, made use of that. Now, some might be familiar with Hedly Lamar and her work on frequency hopping. And they actually used that to do jam-resistant radio communication for remote control of torpedoes. It was looked at for use in radar networks, but wasn't really needed that much. So they used it for torpedoes. The first generation of Wi-Fi technology used digital spread spectrum. Nowadays, we have channel bonding, where actually you use the fast Fourier transform across multiple channels to glue together a much faster signal. This one I didn't know until I started digging down deep into the rabbit hole. The SATA disk interface, the PCIe computer bus interface, and USB 3.0, all considered using spread spectrum clocking, because if your cabling was a little off, the wires weren't all the same length or they were relatively long, and if you attempted to put clock and data on the same set of cables, the clock and the data could get skewed from one another by just nanoseconds. And it turns out it was much easier to just make sure you build it right. But they put the technology into the early chipsets for SATA, PCIe, and USB 3.0, and then found out they didn't really need it. But if you're talking about ultra high resolution location tracking, like if I move an object in a biological lab from this table over to that table, I want to know where the sample is. Well, if you attach a UWB or ultra wideband tracking tag on it, you can actually measure the movement over such short distances with high accuracy. And UWB is kind of like the golden high resolution approach in medical device positioning for labs. So if you discover something and you pick it up and it's not quite right, and you put it back down, don't forget where you left it, because somebody may need to pick that up, advance it a little further, and progress it, and eventually, it becomes useful. And then if you join it with something else like digital signal processing and fast Fourier transforms, you get the solution you're looking for becomes meaningful. And now you can pull signal from noise, and you don't have to have giant antennas or giant wavelength signals, smaller antennas. And this one's fun. So there was a guy named Moller who worked on a thing called the Sky Car. That's the red one you see there in the center. He worked on that sucker for decades. I don't know how many, I'm going to guess millions of dollars were invested in it. And it never quite worked, because he kept having a lofty goal. I'm going to fly this thing up to the atmosphere. I'm going to fly for hundreds of miles, and that required more fuel, bigger engines, and you had to have the engine pods for vertical takeoff and landing rotate, which added motors, which added weight, and the goals were always too lofty, so to speak. I guess pun intended. So it never took off, as the saying goes. As more contemporary lighter materials came into existence and all the advanced technologies for sensing position, the MEMS chips and such, and they settled on, maybe not flying as high, maybe not flying as fast, maybe a 30-minute flight is fine. So now we have more flying vehicles. And when they finally ditched does it really need to be a car? Does it really need to have wings and a tail? And now you have even more of these vertical takeoff and landing electric aircraft. Now, if someday they could just find a way to ditch the propellers and the motors and maybe use, electrostatic propulsion at a very highly efficient level, or photonic propulsion. Might get even more interesting. So this is where it kind of comes to fruition. I saw this week and went, I can see where that's going. Anybody notice that a lot of those unidentified flying things are V-shaped? There's a guy named JP, company named JP Aerospace, and they're attempting to build a lifter. It's a lighter than air craft. So on the inside, there's a giant tube filled with helium, and it's pressurized so they can adjust the altitude they want to go to. And the outside is thin polyethylene, so it can expand and contract slightly as it goes up. They're hoping to get these things to right to the edge of the atmosphere. And then they have onboard thrusters, Hall effect type thrusters, so that they can maneuver to higher speeds once out of the atmosphere and in orbit. The big blue wing with the two little white squares on top is enormous. The little white squares on the top, those are larger than the Hubble Space Telescope. So the idea is when you get one of these things built big enough and it's powered by solar cells, that's the little blue tiles on the top, it can go up into space, into orbit around the Earth, dock with, have the Hubble Space Telescope go into the cargo bay, close the door, and then come back down and bring the Hubble Space Telescope back down. I think it's a lofty goal, as the saying goes, but so far in the lower right there is their current test vehicle, Ascender 36 as in it's 36 feet long. There's enough helium on board that it literally pulled itself up. And when it pulled itself up, it jostled everything inside the craft. So they have more control to do. But this is a group of people that are pushing the envelope, trying to figure out if I can just get past a few hurdles, what can I accomplish with it? So they're definitely visionary. Let's see where they go. But just keep an eye out on JP Aerospace and the Orbital Ascender. If you think you can always spot the things that will succeed and the things that won't. In 1881, there was a guy who created a three-wheel electric vehicle. This predates internal combustion engines. He created his own motors, his own battery technology, and he could drive this thing around. And if you thought internal combustion vehicles were things to be laughed at early on, this came out earlier than that. If you saw what he was driving around in, well, it's just one person, couldn't go all that far, was quite expensive at the time for what you get. But in 2018, the red thing is a Tesla Model S. It's not a Plaid. Plaid came later. But in 2018, that's a Tesla Model S. So the thing on the left is the precursor to the thing on the right. And if all you saw was the thing on the left, and that's all the technology you knew, you wouldn't have the basis for envisioning the thing on the right. But if you knew about internal combustion vehicles and you knew about computer electronics and lithium battery technology, you should be able to conclude that the thing on the right is where it's going to go. And I heard this week that they're planning on changing the chemistry in the lithium ion batteries to use more manganese. And by using more manganese, it makes the batteries about 15% lighter. I think they were saying about 20% less expensive. Lighter and less expensive means you don't need as many batteries in the vehicle for the same range, or you can have the same number of batteries for longer range for a reduced price. So Tesla's not sitting still, even though they've got a dominant part of the worldwide market. They keep improving, even though they have no literal competition knocking at their door. So I think they're probably in, unless they do something just dumbheaded, I think they're going to be dominant for some time to come. So in conclusion, when something is discovered or invented, it may not be able to be put into practical use at the time that it's uncovered. Don't ignore it. Remember where you left it. Don't be discouraged. Maybe do publish it, at least to your peers. And if patenting seems obvious, then obviously try and patent it. If you have the time and the resources, keep refining it and improving it. Always remember the planet has lots of people on it. And so if you're not willing to increase the efficiency, maybe there's somebody else that will, that's using where you started. But you also need to realize that if the technology and what you need is not there yet, maybe reduce some of the lofty goals to something more practical. But sometimes, it may take more than a lifetime's work for something to be practical. Tesla's not around anymore, but his name is on the cars and still a lot of devices we use every day. Maybe what you do today will be used as the early work that others will stand on top of in the distant future, and they'll get the notoriety and the financial reward, but at least, the human species will continue to move forward. Lots of links. Yes, I do look at places other than, oh, I did it. I made the effort to try and not say Hedly Lamar, but I said Hedly Lamar. Her name was actually Hedly Lamar. Hedly Lamar was in a Mel Brooks movie. Okay. Were there any other things that people might have thought of as early on that didn't catch on, but eventually caught on? Had to wait for technology to catch up?
Yeah, many things.
Yep.
Hmm.
Well,
Jules Verne had an idea. Did you ever read Master of the World or Rubur the Conqueror by Jules Verne?
I didn't read them, but I saw the movies. And yes, diving bells, submarines, lighter than air balloons.
Okay, that's a movie. In the book I read, he created, they came up with a device, a large craft that had like 36 air screws, and they traveled across the country using these air screws to lift them off the ground.
That was in the movie with Vincent Price. Yeah.
Oh, was it? Okay. Yeah, I didn't see the movie. I just had the book.
Yeah.
And I'm not sure if they combined or just one. I thought the book had both stories combined, but I just remember the air screws in this device.
Yeah. It was like 20 some odd air screws on top of what looked like a giant boat.
Okay. And at one point in the book, they fly over Dayton, Ohio.
Just to point out the Wright brothers.
No, before the Wright brothers, but it was an interesting coincidence when he wrote the book that he had this craft fly over. I don't think the Wright brothers were known yet.
Oh, okay.
I'm not sure when he wrote the book. I guess I have to look it up.
Stranger things are possible. So, when people think up things and that's a crackpot idea, well, maybe it is and maybe it isn't. Maybe just have to wait a little while, improve it further. Some technology might have to come along. You might have to pair it up with something else, which is why I used to enjoy watching many years ago the James Burke Connection series from the BBC, because you could see if I combine this with that, I wind up with this. In retrospective analysis of current stuff, you can see where things came from. I couldn't have this until I had that, and by having both of them, now I could have this. That all made sense. Okay, I knew it was going to be a short one tonight. Any comments or questions before I stop recording?
No.
Hearing nothing.